Guys, it's Miss Schrader. I thought I would try something different today and take a page from the PowerPoint in the acids and bases chapter. So today I just want to talk about pH. So your reading is for pH and indicators. So today just pH. So as many of you know, the pH scale is from 0 to 14. If you have the lower pHs, so any pH less than 7 is an acid, and a pH greater than 7 is a base. A pH of 7 is neutral. So there's a lot of things that are neutral, like water, alcohols, sugar solutions. So that's all neutral. So just to kind of look at it from a chart perspective, and you can kind of remember this as acid. A starts earlier in the alphabet than B does. So acids have lower pH, bases have higher pH. And again, remember acid means there's an H plus, base means there's an OH minus. So just a little review on water. So water actually does break apart. If you have a glass of water, it does break apart very, very slightly into H plus and OH minus. So you might say, okay, well, does that mean it's acidic or does that mean it's basic? Well, the thing about pure distilled water is that those two numbers are the same. So these brackets represent concentration. So the concentration of hydrogen and the concentration of hydroxide in pure distilled water is equal, and it's 10 to the negative 7th. So if you have neutral water, the pH is 7. So pH stands for power of hydrogen. So even though we have this hydroxide in here, this H right here and the concentration 10 to the negative 7th, that's how we determine the pH. And you're like, well, what do we use to determine the pH? And that is a log. Now, if you're like, I've never done logs, I did logs, I hate them, it doesn't really matter because we're going to do it from a very basic perspective. But it's important to note that logs mean 10. So it's a power of 10, and we'll get into that a little bit more. So in pure water or acid or base or whatever, when you multiply those two concentrations, so if you multiply 10 to the negative 7th times 10 to the negative 7th, hopefully you remember you add exponents, so you would get 10 to the negative 14th, and that's where the 14 comes from. So no matter what, when you multiply those two numbers together, they're always going to be equal to 10 to the negative 14th. No matter what you have, like an acid, a base, neutral, whatever. So if you have more of these H pluses, you're going to have less OHs. And vice versa, if you have more OHs, you're going to have less H pluses. So let's just go back here. If there are more hydrogen ions, this is what I just said, than OH minus ions, a substance is an acid. If there's more OH ions than H plus ions, a substance is a base. So I just want you to understand that these are related to one another. Okay, so back to pH. Again, pH stands for power of hydrogen, and pH is the negative log of the H plus concentration. I'm going to do another screencast with my graphing calculator just to show you, just give you more background on it. So for example, the equation right here is pH is minus log H plus. So a solution with a hydrogen ion concentration of 10 to the negative 10. So if you put in your calculator, if you have a graphing calculator, if you put 10 to the negative 10, press the log button, and then make that a negative, you're going to get a number like 10. If you do the same thing with this one, you're going to get a number of 2. So a solution with a hydrogen ion concentration of 10 to the negative 10 has a pH of 10. Which means it's a base because it's greater than 7. A solution with a hydrogen ion concentration of 10 to the negative 2 has a pH of 2, which means it's an acid. So here's what's a little bit confusing, is it kind of looks like this number is bigger, right, because it's 10, and this number is smaller because it's 2. But remember, this is 10 to the negative 10, and this is 10 to the negative 2. So if I wrote 10 to the negative 2 out, it would be 0.01. If I wrote 10 to the negative 10, it would be 0.9 zeros and a 1. So this number is way smaller, so I have way less hydrogen ion concentration. But the negative log makes this number bigger. So it's a little bit inverse there, right? Okay, so let's just summarize it to see if to kind of put it all together. So each decrease of 1 pH, so think about that. If you're decreasing in pH, you're getting more acidic, right? So represents a 10 times increase in hydrogen ion concentration. Sorry, I'm in the way there. And then that would be the opposite way. So if you're increasing, then you would have a 10 times decrease in hydrogen ion concentration. So let's just summarize this to make it make more sense. So if you have a pH of 1 to 2, remember you're getting less acidic, right? You're getting more basic. That means this is going to go down. So your pH going up means your hydrogen ion concentration is going to go down by 10. Your pH going up by 2, your hydrogen ion concentration is going down, right? Because you're becoming less acidic, but because it's a log scale, it's not 20 or 2, it is 100. And if you go from a pH of 1 to 4, because that represents 3 pHs, right? That's going to be 1,000 time decrease in hydrogen ion concentration. So the things to keep in mind are when the pH goes up, your hydrogen ion goes down. pH of 1 is 10, pH of 2 is 100, pH of 3 is 1,000. Okay, now the opposite is also true. If you're going from 10 to 9, you're getting an increase, right? You're becoming more acidic, so you're going up 10 times in hydrogen ion concentration. If you're going down, you guessed it, it's going to be a 100 times increase in hydrogen ion concentration. And then from 10 to 7 would be 1,000 times increase in hydrogen concentration. So hopefully that makes sense. I'm just going to put another little screencast together just to summarize this, and then I'm going to give you guys a Google form for your homework for today, which is Tuesday, April 28th.